Hi, this is Dr. Carl Goldkamp. If you're interested in learning about the ketogenic diet like I was, to save my own life, then this is probably the podcast for you. 8 years ago, I knew nothing about it. 6 years ago, it saved my life. 3 years ago, I started researching and talking with some of the authorities in the field and attending medical conferences about this to understand why and how keto so dramatically changed my and my wife's Judi's lives. The purpose of this podcast is to share our journey of discoveries with you and understanding how keto is so effective in improving so many different conditions, from obesity, epilepsy, diabetes, infertility, MS, Alzheimer's, heart disease, to name a few. So take a step away from all the hype you've probably heard and roll up your sleeves with me and join me weekly to explore this living miracle that anyone can access. We'll talk science, we'll talk food. We'll explore its history and evolution to today, which is that the sheer wonder of the ketogenic way of eating has changed untold number of lives, unlike anything before it. And in case I forget to mention it, please join our Facebook group, Keto Naturopath. Hi, this is Dr. Goldkamp, and welcome back to another episode of the Keto Naturopath. I mentioned before that I'm doing a series about 7 episodes about cancer. And on the way of completing these 7 episodes, and they are not going to be sequential. I mean, they will be sequential, but not right after each other. So this is one of those, if you will, rabbit holes that we went from cancer to something slightly deeper that actually has to do with weight loss. But we're really going to be talking about metabolic hormones. So we're going to have 2 episodes on deep dive weight loss and keto, which really means we're going to be getting into metabolic hormones on 2 different levels. First one, we're getting into leptin and ghrelin and what that has to do with weight loss. And that's a little more of a better known story of understanding these. We have to sort of get that out, explain that, and then we're going to go on to talking more in depth about incretins, which I touched on in the last episode, because I think you really need to understand how that has to do with not macros, but the processing of food. And I'm not speaking, so I'm going to get back to that. Without getting too deep into it, I'm going to get back to that. I think that's very important to know, and putting these 2 things together explains a lot about how we are. Okay, so let's get in. So when we talk about, why are heavy people heavy, and why are obesity or morbid obesity, how can people get to be that large? How can you get to even be partially that large on the way? How is it that it's difficult for you to lose weight? Well, a more standard, if you were to go to your community college and do your adult class on, it might even be weight loss, they will tell you about this story, which is leptin and ghrelin and so on. And then they might get into calories, and they might get into physical activity, but that's as far as they're going to go. We're going to cover the first part, which is a little more sophisticated and things you need to know. Okay, and so let's get started. So the reality check is most people who go on a diet to lose weight end up regaining it within a year. That's just the reality. We're talking about in the 90s, 90+%. So that's sad, and that's just the reality. And most of you who are listening to this now, if you're listening with the intent for picking up a secret on weight loss, we're going to get to the combined secrets over the next 3 podcasts. And it's kind of implied throughout all my podcasts, actually. But hang in there. The punchline is going to come stronger in the next podcast, and certainly the one after that. Okay, why does this happen? Why, relative to the view we're going to have on life for these next couple podcasts on leptin, which is a hormone, and ghrelin, which is a hormone, why does this happen? Well, obviously, there's many reasons. The big one is that people view a diet as a short-term solution and don't really change their behaviors, which is why the need is to focus on a more sustainable approach to create a permanent change. And that's hence the podcasts, hence what we do. Keto Naturopath and our coaching programs, and our flagship coaching program, the Biointegration Code. Okay, another reason is that our bodies have appetite and weight regulating hormone mechanisms that try to maintain homeostasis, keeping things the same over the long haul. When we constantly take in less energy in the form of food, So we're told to, gee, if I eat less, I'll burn the energy. Well, that's, on a mathematical level, that's actually true. So somebody is speaking the truth, but on a metabolic level, that's not true. And somebody's very outdated. And they're probably making you feel bad in the process if that's what you're hearing. Okay, so you take in less energy in the terms of food, and then you expend through basal metabolism in activity, as in diet or a famine, that is through fasting or starving, or working out a lot that you've burned up these calories. Our bodies respond by making us hungrier. Our bodies generally don't want to change. They just keep things the way they are. They, like everything, to stay the same. If we try to change this, our bodies will respond with compensatory mechanisms. They will bring you back to what used to be called your weight set point, or your set point for weight. That concept's being challenged. So we're not all, and I'm going to get into that. So we're going to be moving away from that, but these are terms you need to understand. These are references you need to understand. Okay, so we're moving away from that set point, weight set point, such as reviving of our appetites and hormones. Two important hormones that shape our appetite and hunger signals are leptin and ghrelin. So what are they? Hormonal control of appetite and body fat is what they do in a combined fashion. Leptin and ghrelin seem to be the big players at this level of looking, at this level of viewing, and regulating appetite, which consequently influences body weight fat, right? So obviously you're hungrier, you're going to eat more. You can endure being hungry for a period of time, but you can't endure being hungry for a prolonged period of time. When we get hungrier, we tend to eat more. When we eat more, obviously, we maintain our body weight, or we get back to that, we get the weight back that we lost. Both leptin and ghrelin are peripheral signals that with central effects on our nervous system, on our brain specifically. In other words, they're secreted in other parts of the body peripherally, but affect our brain centrally. Leptin is secreted primarily in fat cells, as well as the stomach, the heart, placenta, and skeletal muscle. But you never knew that. And by the way, it wasn't that long ago in which people thought that fat cells, adipocytes, had no function at all. They were simply storage rooms. So that idea has been changed a lot. Leptin decreases hunger. So it makes sense. If you have, in the perfect world now, and we're going to change the perfect world. Perfect world is that you've eaten, you've stored your fat, which is an addition, an extra amount of energy that you needed, so it gets stored. Your fat cells register that they're stored, and they send out a signal saying, you don't need to eat anymore. Stop anytime now. Makes sense. It's positive feedback. Sorry, it's negative feedback mechanism, just like your thermostat in your house. Okay, so leptin is secreted in the fat cells, and the heart, and the placenta, and the skeletal muscles, and it decreases hunger. Ghrelin, G-H-R-E-L-I-N, is secreted primarily in the lining of the stomach. So ghrelin is secreted from one place. Leptin is secreted from a lot of different places, a lot of different organs, pretty important organs. But it is in the stomach as well. Heart, placenta, skeletal muscle. Okay, so ghrelin secreted in the stomach, and ghrelin increases hunger. That makes sense. So when your stomach is empty, thinking of the walls of your stomach touching each other when your stomach's completely empty, it says, all right, time to fill the sucker up a little bit or get something in here. So pretty straightforward. The logic is pretty sound. Both hormones respond to how well fed you are. Leptin usually also correlates to fat mass. So the more fat you have, the more leptin you produce. Both hormones activate your hypothalamus, part of your brain, next to your pituitary, as part of your brain about the size of an almond. The important point here is that both hormones and their signals get messed up with obesity. So that perfect equation of fats getting stored, signals, hey, stop eating, Your stomach's empty. It says, hey, let's eat. It starts to get, the messages aren't getting through. So what's happening? Ghrelin and leptin both act on the brain, the hypothalamus, which is right next to the pituitary. So back in 1994, researchers noticed that one genetically altered strain of mice ate a lot and was obese. When researchers administered a new substance, leptin, the mice lost weight. Soon after, nearly everybody was interested in fat research and was doing research on leptin. So that was just back in the mid-90s. So we're now talking barely 25 years ago, 26 years ago. And they say it takes 20 years for research to get into the public knowledge. I guess that's about it. But so when I was in medical school, which was in the mid-90s, we were just starting to hear about leptin. It was a little bit beyond my understanding. But I remember when we were in the Czech Republic, I was there for hydrotherapy instruction for a couple of weeks at the medical institute, that leptin was, these guys were already talking about it. And I go, what is leptin? These guys are talking about leptin. And they looked at me like, well, you're not that in the know, are you? And apparently I wasn't or the group that I was with. So I realized you listen to other people's opinions and you listen to other experts around the world. We are not at the cutting edge. We're part of it, but we're not at the cutting edge. Okay. So anyway, soon after that, everybody was doing research on leptin. And at the time, this was the holy grail of obesity research, a protein, which is leptin, that made really fat mice into skinny mice. Fantastic. You just took your leptin pill. They just took their leptin pills, and look what happened. Okay, and everyone will be ripped. Leptin pill, boom, there you go. Well, like most things in biology, leptin is more complicated than that. As it turns out, leptin injections only worked on mice and people who were genetically leptin deficient. So if you didn't have it, it goes back to deficiencies and taking supplements and so on and so forth. Supplements work if you're deficient. If you're not deficient and you take more supplements, they're not going to improve your situation. They're going to drive an excess, which will drive other deficiencies. So anyway, here's another rule I'm trying to point out. Only about 5 to 10% of obese subjects are deficient in leptin. The other 90 to 95% were SOL, or out of luck. How does leptin work? Leptin is made by fat cells, adipose tissue, and is secreted into the bloodstream, circulatory system, where it travels to the hypothalamus. Leptin tells the brain, the hypothalamus, it gives you feedback saying, hey, we've eaten enough fat, so to say, primarily it's fat. We've eaten enough fat, so let's eat less or stop eating. Leptin may also increase metabolism. Also, there's a conflicting research on this point, but it kind of makes sense. Generally, the more fat you have, the more leptin you make. The less fat you'll eat, the higher your metabolic rate. Let's repeat that. Generally, the more fat you have, you're a heavy person or obese. That means you're making a lot of leptin. Supposedly, that means you'll eat less food and you'll have a higher metabolic rate. You burn off calories more quickly than other people. Conversely, if you eat less fat, you'll have less leptin, basically for weight loss. Eat less leptin, you'll have, and the hungrier you'll be. Basically, for weight loss, the more leptin, the better. That's the pure, simple way of looking at things, right? It controls your hunger. Eat too much, it says, back off, we're good. It's your satiety hormone. Not society, satiety hormone. You're feeling satiated. Leptin resistance. You'd think then the fatter folks would somehow magically stop eating and start losing weight once their leptin levels are high enough. Unfortunately, you can become leptin resistant. In that case, you can have a lot of fat, making a lot of leptin, but it doesn't work. The brain isn't listening. No drop in appetite. No increased metabolism. Your brain might even think you're starving because as far as it's concerned, there's not enough leptin. In other words, it's not getting the message. So that means it's not so much that you're not producing the leptin, right? You're not the deficient people, we're going to assume. You're not producing enough. You're producing plenty, but somehow it's just not getting the message. So that means there's receptors, there's whatever are the other things that gets the message through to the hypothalamus are being blocked, altered, or removed. So you're hungrier. So it ends up being a vicious cycle. And this is what a lot of obese or heavy people will talk about. It's a vicious cycle. The more you eat, the more you gain fat. The more body fat means more leptin in fat cells. Too much fat means that proper leptin signaling is disrupted. The brain thinks you're starving. In other words, even though you're producing all this leptin, it's not getting the point, which makes you want to eat more. You get fatter, you get hungrier, you eat more, you get more fat, and so on and so forth. So that's how it goes, and that's pretty much the story that anybody who's obese saying, I do all this stuff, but it's just not working for me. This is why they are telling the truth, and this is why it's not working for them. So you got to go a little more deeply at looking at this. Remember, it's a multi-podcast situation, but we're laying out some really basic things so we can build on this, so we can have a more sophisticated conversation a couple of podcasts on the way. Leptin resistance is similar to insulin resistance, and they share the same common signaling pathway. Though obese men tend to have more internal body fat. Both types of resistance seem to occur together in obese people. Though obese men tend to have more internal belly fat, which is called visceral fat or visceral adipose tissue, VAT, and they have higher insulin levels. And women who tend to have more fat under the skin, called subcutaneous fat, have higher leptin levels. Interesting. So you'll notice on some women, an example would be as women get older, they get upper arms that have these, what they call bat wings, right? Don't laugh. And so that's an example that you can visualize now into what subcutaneous fat is versus visceral fat. And you'll find that men get pot-bellied more so than women. Another leptin-resistant fact is that fructose, so you get fructose from all sorts of sweet drinks, and you get fructose, yes, from fruit, seems to induce leptin resistance. So there are a few possible explanations of how leptin resistance actually works. One theory is that leptin can't get to the hypothalamus because the proteins that transport it across the blood-brain barrier aren't working or aren't there, since there's a buildup of leptin in the cerebrospinal fluid. So it's backed up in it. They found it, hey, you didn't go here, you went over there. So you're not supposed to be in this cerebrospinal fluid. You're supposed to be in the brain, across the blood-brain barrier. So they're being prevented from crossing the BBB, as I say. Okay, then. Similar to insulin with dementia. So when we talk about dementia, whether it's Alzheimer's or general dementia, we're talking about nerve cells that can no longer or have restricted access to glucose. So why would they have restricted access to glucose when we also talk about dementia as type 3 diabetes? Well, we know that also they usually have high insulin, so they're insulin resistant. So they have plenty of insulin, too much insulin. Insulin is less sensitive, it's less potent. But really what happens is because the insulin has been, over time, gotten to have this steady state of a higher and higher and higher level. Its normal levels are higher and higher and higher. Well, when that's the case, your nerve cells automatically prevent, insulin forces glucose into nerve cells and fat cells. And so that's kind of the good thing. That's the job that it does. But when you keep on getting too much glucose as a automatic and good response, it starts blocking those entries. So it's like, we don't need that much glucose. We don't need that much glucose. So it either downregulates receptors, gets rid of the number of receptors, or does some other blocking ability. So consequently, you find in brain cells, and I'm talking about dementia, as much as they are bathed in glucose, they're not getting that much glucose. And nor can the insulin be that effective. So your insulin becomes less and less effective. And so your insulin producing cells, primarily your pancreas, produce more insulin. So that's how that goes. And so it's an endless cycle. So, well, how do you pull back from that? Well, pretty much the same way you pull back from leptins. And we're going to talk a little more. So that was a little bit of a digression, but know that leptin, there is a thing called leptin resistance, and certainly there's a thing called insulin resistance, which you can calculate, and we can, and it basically means you have a high amount of insulin for your blood sugar levels, your glucose levels. So regardless of the actual mechanics, the important point here is past a certain level of leptin, and you can even insert insulin, having more body fat can screw up your appetite signals and actually make you hungrier. So that whole normal negative feedback mechanism, the perfect little picture, works within a certain degree of normality. Once you exceed that, it's no longer working very well. Okay, ghrelin, the other hormone, the one that is about hunger. And remember, it's secreted from your stomach only, so far as we know. The stomach only, not from all these other places. But it also affects your hypothalamus. All right, so ghrelin is high before you eat and low after you eat. Makes sense. High before you eat, hungry, drops. Okay. If you want to lose weight, you want less ghrelin. You don't want to be hungry. So you don't get hungry if you don't want to gain weight. Say if you're scrawny, then you want more ghrelin, or at least you want to stay at a higher level of ghrelin, so you eat more, so you don't stay scrawny. Both hormones regulate appetite and hunger. Both of them regulate homeostasis, and in this case, keeping you adequately fit. When you try to lose fat, your body will probably respond by changing your hormone levels so that you get hungrier. So it's really just on this mechanism of looking, which is really where the conversation's been for the last 25 to 26 years, that, it's a pullback mechanism. It's hard to break, hard to get off that level. It's no longer completely true, but it works. It's a good explanation. So the body will probably respond by changing hormone levels so that you get hungrier, that you stay at the same fat level, if you will, same weight level. Obviously, this presents a challenge for folks trying to lose fat and keep it off, leading perhaps to the yo-yo dieting that everybody talks about. Okay, so then this presents the question, can leptin and ghrelin levels provide some explanation of the ups and downs of dieters' experience? Well, as this whole little outline of this conversation is it's a little more complicated than that. Why? How is it that leptin gets to be leptin resistance, and how does all that stuff get started? Okay, so to help go a little deeper in leptin and ghrelin and relative to how this affects weight, obesity, hunger, et cetera, let's look at a study. So out of August 18th, 2010, from the Journal of Endocrinology Metabolism, we're going to look at an experiment that was set up. And here's how it goes. Researchers put 160 obese and overweight men and women with an average BMI of 31, that means they're obese, remember 30 and over, BMI is obese, on a calorie-restricted diet for 8 weeks. The diet was 30% less calories, about 600 calories fewer per day, than the participants' total energy expenditure. So they just shaved off 600 calories per day, with 15% of the calories coming from protein, 30% from fat, 55% from carbohydrates. This actually could be considered a high carbohydrate diet. And I'd have to calculate the height and weight of these people and so on and so forth. From my perspective now, for where I am in my life now and what we're doing, I would say this is way high carb, way low protein, and maybe adequate fat. So it's a pretty screwed up diet, but at the time, think of 2010, this is like sophisticated science and thinking, gosh, we're really going to nail down some parameters here. But anyway, I thought I'd interject a little current perspective. There was no change in physical activity, just less food. Researchers measured body weight, body fat, and waist circumference. They also took blood samples. They measured leptin and ghrelin taken before dieting, right after dieting, 8 weeks, 6 months later, and then 32 weeks later. So that's 3 years, just under 3 years, 2.5 years later. Results were, after 8 weeks on the diet, most lost an average of 5% body weight. Most men lost slightly more, 6% on average. Most women lost 4.5%. They lost an average of 1.5% body fat, and they all dropped about 4 centimeters off their waist. So the gainers and losers, but the average doesn't give us the whole story. Some folks lost more than 5% of their weight. Others lost less. This may seem self-evident and not that interesting until you look at the blood samples. Dieters who lost more weight, that is greater than 5%, had a bigger drop in leptin and insulin compared to dieters who lost less weight, under 5%. However, losing weight is correlated to drops in leptin and insulin. Remember also we talked about how insulin and leptin went together. They both have resistance. And so when we've done lab work and people in our programs, you do get varying effectiveness. And really the goal of the program is to bring them all to a pretty high level of effectiveness. So we all start at the same place. We get the details, about to say diagnosed, but no, we're not diagnosing anybody. We get the details borne out. And so some need greater support in certain areas. And some might be micronutrients. Some might be faster dropping the fat component, as we get into it. But so everybody's different, even though we're working with the same sort of rules. So here we go as well. So what we see is, I'm just summarizing, it was basically those who dropped the insulin and those who dropped the leptin lost more weight. Pretty straightforward. So they had the mechanism in place and their sensitivity was still valid enough that they could quickly make a change. Okay, 6 months after the diet ended, the split continued. Half the group lost more weight. Half the group regained the weight as they lost. Blood levels of leptin and ghrelin were correlated to weight loss or regain. And this effect often dependent on sex. So that's why when you talk to your wives, your girlfriends, or just men and women in general, the women generally complain, especially on the ketogenic diet, is like, oh, my husband got all these effects and the women didn't. The women will get it with time, but they are different. That's why we look at hormone panels. It is a difference, and you have to have this conversation. Sometimes in some of the groups we have, it's just women, and sometimes it's just men, and we can just go deeper into talking about certain hormones than others. Okay, women with lower blood leptin at the end of dieting were most likely to maintain their weight loss, but ghrelin didn't seem to make a difference, so up or down. Men with higher ghrelin levels at the end of dieting were more likely to regain weight. So ghrelin with higher hunger, so those who had higher hunger hormones at the end of dieting were more likely to regain weight. But leptin didn't seem to matter, so it's just the opposite for women. For both men and women, insulin levels at the end of dieting didn't seem to matter in the long term, although insulin levels did increase when weight went back up. For both men and women, ghrelin levels were higher, hunger levels, meaning they were hungrier, at the end of dieting, but in the weight losers, ghrelin levels dropped. They weren't hungry. They became less hungry, in fact. So, what do we see? And then I'm looking at a study, so I see various diagrams. I'm just going to skip through all that. Maybe when we start presenting on YouTube, I'll get to that. It's be worth going over. And so what are we going to say with all that? Well, there's a couple things I want to say. First of all, let's look at the study design. First of all, this whole conversation is based on macros, right? We're assuming that all proteins the same, all fats the same, all carbohydrates the same. And that's really an inane assumption. So whether you're eating Cheetos or whether you're eating salads or whether you're having, because people were having carbohydrates, whether you're having a protein drink or whether you're eating steak, these are significant differences that clearly are not taken into consideration here. And remember, this was based initially on discovery that leptin made fat mice drop their weight. And oh my gosh, let's look into leptins, and found out that actually it only works for humans that are deficient in leptins. So we're going to go deeper into that because if you're looking at the ketogenic diet, even though that is a descriptor of macros, hey, it's a high fat, it's a low carb, high fat, moderate protein. I hear that so often, it just starts to sound dumb after a while that and now you know that that only works for 50% of the people. So why is that? Well, the reason is because you're not qualifying the kind of carbs at all, or if you're having carbs at all, what kind of carbs they are, what kind of fats you're having. That's a big difference, the kinds of fats. We've talked about that on past episodes. And what kind of proteins are you having? Are you having a whole food protein? Or are you having a protein because you saw it in the label? There's some protein in your potato chips. I'm making it up. So the kind of foods you eat, the whole foods or not whole foods is what I'm getting at, is really important. And that has its own effects. And we're going to be getting into that with talking about incretins more deeply. And so I want you to come away understanding that the kind of food you eat is immensely important. It is not just macros, but even on our program, yes, we do have everybody track their macros. We need to be able to have a conversation that we have the same terms down and we can sort of review the week. And that's why we focus on whole foods. So we have macros and whole foods. Nobody has processed foods in our programs. We're just not even going there. If people can't make the change into having non-processed foods, we can talk about addiction and I can have some suggestions there, but it takes work to move away from the spot of total convenience. There's a lot of easy ways to do it. Anyway, so when we talk about keto, we talk about macros, and it is equally inane, but it had a greater truth to it, saying it's high fat, low carb, and you began from there. Okay, what else can I tell you about? So a little on the discussion of the research is, so the biggest hurdle dieters face is weight regain, and dealing with it is a big problem. Appetite is controlled by a host of complex interacting factors. The study suggested that hormonal mechanisms may be different than men and for women, and among men and women. The difference may reflect the different hormonal environments in men and women. For instance, ghrelin, remember the hunger hormone, seemed to be affected by growth hormone release, which differs in men and women. Leptin seems to influence the reproduction and fertility in women. So it's not just about feeling satiated or not, which is related to a woman's body fat levels. Women appear to be much more sensitive than men to leptin levels, unless men are given estrogen. Here's another add-on to that experiment. Intranasally, up your nose, administered insulin makes men less hungry and lose weight, but it makes women hungrier and gain weight unless women's estrogen is low or unless men's testosterone levels are low. So what's interesting here with men specifically is that if they are obese, they more than likely will have low testosterone levels because it blocks what they call an aromatase. It's a cortisol and insulin is an aromatase inhibitor. So anyway, so I'll repeat that. When they gave insulin intranasally to men and women, they found that it made men less hungry and they lost weight. Those two go together, right? You less hungry, you eat less, you lose weight. But it makes women hungrier. So you're hungry, you're going to eat more, and they gained weight. The exception was if women estrogen levels were lower or if men's testosterone levels were lower. So if they had low testosterone, men, then they probably were not going to lose weight and become less hungry. If women had lower estrogen levels, they probably were not going to be hungrier and they were not going to gain weight. So you think of cycling women, when are their estrogens high and when are the estrogens low? They control a lot. And so the leptin is also part of that. However, there are also important differences within groups as well. Some men lost weight while others regained it. Some women lost weight while others regained it. That's always the case. As the researchers pointed out, these findings suggest the existence of two different populations according to the leptin and ghrelin levels are influencing the outcomes. We expect that folks who regain weight easily will have lower leptin and higher ghrelin. Lower leptin, meaning they're not going to feel as satiated, or they don't feel as satiated. They have higher ghrelin levels, means they're hungrier all the time. So they're going to eat more. And that wasn't the case in the study. The researchers proposed that these results are consistent with a disruption in the sensitivity to these hormone signals. That's probably the bigger issue. It's a bigger truth that's being presented, probably in the central nervous system of those subjects with a higher predisposition to regain their body weight. So what's being disrupted and how do you change those things? Still remember, all these studies they're just talking about macros. So we still have a whole area to talk about, and that's where incretins come in. This suggests that obese people, leptin and ghrelin signals may not always work in ways that we expect. Obesity can disrupt normal appetite signaling. I so wish in these, you want to put in, so what were they eating? Just don't talk about macros. What did they actually eat? So if they're carbs or potato chips, as opposed to green salads, tremendous difference. We'll never know. There's more to the story, of course, which we'll go into in the next couple of podcasts. So I wanted to set down that you now are familiar with these two terms. You're now going to be familiar with leptin and leptin resistance. So that's the satiating hormone. And yeah, there's a problem with it. It doesn't always work. And then the other hormone is ghrelin. That's your hunger hormone. And it doesn't always work. But that it works on your brain. So getting the signal to your brain. So that should be interesting enough. I'm going to leave that to you as we get further into what we're going to call metabolic endocrinology, metabolic hormones. So metabolic endocrinology appears to be slightly more complicated than a nuclear reactor or brain surgery combined, meaning it's not as straightforward as we think. But when I take labs, I'm very happy and feel very satisfied to have my glucose and insulin levels documented. And then I look for homocysteine. Then I look for inflammatory markers. And I look for your omega-3 and your omega-6. We're going to get into that in a little bit. These are things that paint a bigger picture. Nothing is just one thing. That's the thing about marketing nowadays, especially if you go on things you can buy on Amazon. Just one thing is going to change your life. Just one thing is going to change your life. No, it's not. If you're deficient in that one thing, it will change your life for a little bit, and then it's going to make a problem for you. So what are we going to do? I'm going to skip future things coming up. We're going to talk about fish oil, sleep is important, and understanding more about fats and incretins. Okay, so next is deep dive weight loss and incretins as it relates to the ketogenic diet. Till next time. Bye-bye. Hi, this is Dr. Goldkamp. I just wanted to encourage you to send in your questions to Dr. Goldkamp at ketonaturopath.com. Many of you have, and so what I've done with these questions that gotten back to most of the people I email, but some of the questions that were so good, and if they were overlapping to other questions, I would combine them and try to put that into the topic of a podcast, either via one of the micro topics that are covered in an interview. As you know, we cover a lot of topics in any given interview, or some of my own sort of reporting, if you will, on some of these issues. So please keep the questions coming. Feel free to send in an email, and I will get back to you. One thing I want to say, a number of questions have come in which I've given this answer, and the email didn't work. So just make sure that you're receiving at the same email that you sent it in. And I think that might have been the difficulty. So I look forward to your questions. I just wanted to make sure that you knew that I'm open to answer your questions. And I think this world of keto is not just black and white. You know, it's nice that it's simple, but it's not simple for some. I'm really trying to, go down as any of you who have listened to all my podcasts. We started way back when, history and evolution and epilepsy and so on and so forth. now we're seeing some tremendous overlap in various mental disorders, such as schizophrenia or neurological disorders that are not just epilepsy. And also, just for people and losing weight, it's sometimes pretty complicated for them to engage in keto. And so they need some help. And so that's the whole point of, at least that's what I think I'm doing, is exploring the world of why are there other factors. And so in exploring some of those other factors, we've covered addiction, we've covered hormones, we've covered nutritional deficiencies, we've covered certain metabolic lab results, and we'll go further. We'll even get to more on genome and aspects. So these are all just contributions that make for an obstacle for some people to engage easily in the ketogenic diet. This is my belief, and these are the things that I've discovered. And I think other people have discovered some of these things, but not ever put them together. So stay listening, send in your questions, and I will definitely get back to you.